senior lecturer in freshwater ecology at Lawson University, and I didn't go to university until I was 33 years old. I never walked through the door of a university, so I came from a background of driving trucks and building houses and things like that into the academic world, and I loved it, and I did quite well. I think my supervisors were pretty pleased with me. I did a master's degree with first class honours and a PhD, and I published, which is what it's all about in academic circles, is publishing papers, and I published 10 papers out of those 2 bits of work, and so everybody thought that, you know, here's this guy's going to go great places. But what happened along that progression for me was the realisation that while I was working on freshwaters and freshwater fish especially, what I was going to end up doing was having a career cataloguing the decline of freshwaters in this country and freshwater fish especially. So at some stage, and I can't remember exactly what it was that made me realise that I wasn't going to. I'm a Kiwi, and I grew up believing this was a clean, green country. You could swim in any river in this country, and there was no way I was going to make a career out of it. Just writing about it, and not trying to fight without trying to fight. So that's why I'm here, and that's why I've been around the country, and thanks for inviting me along. So I'm going to talk about where we are. I mean, I'm not familiar with what the local situation is. What I wanted to give a feel for is the national situation, where we're going as a country. How do we get here? Talk about what the sort of things that we're talking about. So many, I mean, I spent a couple of hours talking with the team here about freshwater. I could talk for days, and I've only got a few, 20 minutes tonight, so I'll just have to cram it into a little area, but it's really complex. And it's not something you can just have one measure for the health or the state or water quality. I'm going to talk about the National Objectives Framework. So every council in New Zealand, including here, has been doing their own thing around freshwater. So we have this national policy statement, which is supposed to bring this all together so we have one way of approaching things. Whether or not that's a good idea is arguable, and I want to talk a little bit about that. And especially one of the big issues here is sediment in freshwater, rather more than what the problem is for the rest of the country with nutrients. So I want to talk a little bit about that as well. And then, finally what we need to do to change things. So just as a background, 74% now of our freshwater fish species are listed as threatened with extinction, as well as our only mussel, kakahi, and our crayfish as well. And I have to emphasise that I can't find another country in the world that has such a high proportion of their freshwater fish listed as threatened. The global average is about 37%. The only other country I could find nearest was South Africa with 63%. So it's telling us more than anything else we can measure in our rivers. This is telling us we're doing something incredibly wrong. And it's happened really quickly. This is what's happened in my career time. So there was, 1992, it was 20%, 22%, I think, of our freshwater fish were listed as threatened. And now in 2013, we're up to, in 2013, we hit 74% of our freshwater fish species listed as threatened. 44% of our lakes are listed as polluted. That means they're eutrophic. That means that they've got more nutrient coming in than they can handle, and they're flipped into another state. So nutrients are great in that they grow grass and they grow everything we need, but freshwater systems can only handle so much, and then they go into another state, which is when they become eutrophic. They have too much nutrients in there, and they start to become unhealthy. 40% of all of our lakes, 84% of the lakes that are in pasture catchments and the lowland pasture areas. So just about all of our lakes down the bottom and the lowland areas have flipped into that other state. When you think about the human side of what's happening with our freshwater, the Ministry of Health reckons that somewhere between 18 and 34,000 New Zealanders get waterborne diseases every year. They won't all come from freshwater, from rivers and things, but they think it's a huge underestimate because people don't always notify. And we now have a world record, along with the world record for freshwater fish species. We also have a world record for the highest levels of these zoonoses, these diseases that come from things that live in freshwater. More than 90, and where this is coming from, more than 90% of our monitored lowland pasture and urban rivers, so the ones that are urban catchments and pasture catchments, fail at some time during the year the Ministry of Health guidelines for the pathogens that are in the water. That means that you went swimming at that time and got some water in your mouth, there's a high probability that you would get sick. when they modelled that out just recently over the whole country, 62% of all of the rivers in New Zealand would fail that standard. So it's widespread and it's getting worse. When we look at, this is looking at nitrogen levels, just to give you an idea around the country, and I'll come back to this, but where all those arrows are, and they're all showing significant increases in nitrogen, and this is mostly from dairy farming. We now got a huge amount, we've had an 800% increase in nitrogen fertiliser use in this country in the last 24 years. And so each one of those there's 77 arrows in there. Some of them are little crosses where there's no significant trend, but nowhere's getting better, everywhere's either stable or getting worse. That's the National Freshwater Monitoring Data Set that NIWA's been doing now for 24 years, and I'll come back to them. The thing this is a really important point. So there's 77 sites, 33 of them were selected to be baseline sites. That means they were the control sites, the ones that were selected to be above any farming or any development. And the rest of them are the impact sites. So you can see there that are downstream. So what I've got here is just the proportion in every year for the last 22 years, of sites that failed this guideline for nitrogen, 0.61 milligrams of nitrogen. And you can see that the control sites, the baseline sites along the bottom, only 5% of the time in the beginning of 1991 failed, and it's crept up to about 7% of the sites failing that standard. The impact sites, 27% failed back then, and you're up to about 37% now. Okay, so there's a clear difference between those two. But guess what? They get reported as one. So this is part of the reason, because the politicians, the information they get is those two lines averaged, and so it looks like things aren't that bad. And the justification as well, that's representing New Zealand. But it's not. We were given these clean rivers. We started off with clean rivers. So we can't go reporting the ones that we haven't touched as being okay and averaging away the problem here. The problem is the downstream sites, and they're the ones that we should be reporting on, and they shouldn't be averaged. There's no other scientific study where you take the control and impact sites and combine them and average the results. You're just averaging away reality. And this is a big part of the problem, is that not accepting that we have a problem means we don't do anything about it. Wherever you look around the country where intensive farming is happening, we've got nitrate levels rising in the underwater water, the groundwater. As a country, more than 90% of our wetlands have been drained. And this, if you want to think about wetlands, it's not just fantastic places where birds live and fish live and all that kind of thing. As a functional thing, they're the kidneys of our system. They're exactly like our kidneys. They do all the water purification stuff. They take the nutrients out of the water and they turn it into plant material, and they give out fresh water, plus they absorb floods and a whole lot of things they do for us, and they do for fresh water. Think about what you would feel like if 90% of your kidney was gone. And in some places like Manawatu, 98% of them are gone. So before we do anything else to our rivers, we've already lost a really important component, and that's the freshwater part of it that's coming into it. Then downstream, the estuaries. What happens on the land it piles up in the estuaries and off the near-shore environment. So it doesn't end with our rivers. We have to think of them as continuous systems and what happens at the river. So you've got big impacts happening with sedimentation of estuaries as well, with eelgrass being blocked out by sediment, and so that we now, instead of having snappers spawning at a heap of harbours around the country, there's really only one, the Kapia harbour, where they still do it. Kapia's one where that's just hanging on. There's only 2 harbours left in New Zealand, for example, where snappers spawn. So what we do on the land, what happens there affects ocean fisheries as well. It's not a closed system. To give you an idea of how we stand globally, the gross primary productivity, this GPP here, is just simply, to simplify it, as a measure of the fluctuation in oxygen levels. I think this is what it looks like. This is, each one of those peaks and troughs is a day. So when a system, like I was explaining with those lakes, it happens in rivers too, you get so much nutrient coming in, a whole lot of algae grows. The algae is a plant that respires, so it pumps out oxygen during the day, and it's peaking at 4 or 5 o'clock in the afternoon, and it's troughing out at the bottom there, 30% dissolved oxygen, at 3 or 4 o'clock in the morning. And unless your fish and life in there are like a goldfish in a bowl, with, you know how you can see them when they suck oxygen off the surface, unless they can do that, and most of our native fish can't do that, then they're dead at that bottom end. The same at the top end, where it becomes super saturated, the fish get a version of the bends at the top end. So this oxygen fluctuation, the difference between the top and the bottom is a measure called gross primary productivity, and a whole bunch of rivers around the world get measured that way. The score for the Manawatu River, so a healthy river is 0 to 3, 3 to 7 is a satisfactory river, and greater than 7 is considered to be an impacted river. The Manawatu River scored 107. That's worse than anywhere. Of the 570 places in the world that it's been done at, that was the highest it's ever been recorded. 80 was the next highest, and that was in Belgium or Germany, the lower wastewater treatment plant. So this is putting this into a global context of where we are with fresh water. I just chucked in some local, this is some work from Auckland. You can see those comments. This is showing you, so that's just a bunch of rivers in Auckland. And you can see in a healthy river at flat lines, and in winter time at flat lines, because the algae's been washed away by floods or smothered by sediment or whatever. It's only for a month or two that you get those big fluctuations like that top graph, and that's when everything dies. But of course, it doesn't matter that most of the time it's okay. So when you hear people say, well, 95% of the time it meets the standards, just think about us being in this room here. If 5% of the time there wasn't enough oxygen, we'd all be dead. It wouldn't matter that 95% of the time there was enough oxygen. So when you think about averaging things out, you've got to think about how silly that can be. So there's a measure of the health of our freshwater fish communities that's called the IBI, and this is some work. That wiggly green line is the last 40 years of data, 30,000 sites in our freshwater fish database. So the measure dropping over the years, and if you continue that line at that rate of decline for the last 40 years until 2050, we don't have any native fish left. If we keep doing what we're doing, what we have been doing, then we don't have any native fish left by the time we get to 2050. So where is it all happening? This is that same IBI score, and I've broken this, and you can have a look at this on the Ministry for the Environment's website. So it's just broken into these different land use classes, and you can see that pasture, urban, and exotic forest are low, and bare grounded as well. They're relatively low compared to indigenous forest and scrub, which are up higher at that end. Exotic forest comes out looking bad because while a mature forest is good for a stream, at some stage it's going to be chopped down, and that's when it has the impact. The sediment ends up in the river, and you have the decline. So taken over time, the exotic forest is bad. And this is looking at the decline in pasture, just showing over those 3 decades there, the decline is happening faster in pasture than it is anywhere else. So what we've ended up with now is 2 New Zealands. We've basically got the conservation estate where we've got some of the most fantastic lakes and rivers in the world, and cleanest rivers, but then it's down the bottom end that we've got all the problems. That down below 400 metres where we've had all these other impacts from land use changes over time. And the thing is about this is that the true costs are not being paid. And I'll just give you a couple of quick examples to get those numbers in your head. If we look, and I can't give numbers for sediment, which is the main impact here, but I can for nitrate, which is what's come from dairying, and potentially you could have more dairying happening in this region. And this is some work from Lake Rotorua. To get a ton of nitrogen out of the lake, the only way to get nitrogen out of the lake and all those issues that it causes that we know of, or the only cheap way to do it, is to use a floating wetland. And it costs around $240,000 to get a ton of nitrogen out of the lake with the floating wetland. If you go up onto the dairy farm where it's coming from, and the dairy farmer uses 1 tonne less of nitrogen fertiliser, it'll cost, his loss of revenue will be $6,600. So this is $6,600 not to do it on the farm versus $240,000 $4 million to get it out at the other end. 37 times cheaper not to do it. And that goes for so many systems. That would be the same kind of ratio of what you're doing. If you look at nitrate poisoning of what happens to our rivers, So nitrates from farming mostly, and horticulture, but from dairy farming especially to the urine of the cows that it comes in, then you can put a price on what it costs to clean it up, because there's the drinking water standard, which is 11 milligrams, which is what would kill a baby in drinking water. So say that was 11 milligrams, and down here 6.9 milligrams is where it's toxic for fish, and down here was back at that 0.6 that I showed you on the map. So that's where it starts to affect ecosystems. So most people can't, it's hard to understand that fish are more sensitive than we are. But they are, because they have to live in it, we only have to drink it. We can actually, as adults, we can handle this much nitrogen in our water. But to get that water from exceeding that drinking water standard down to a standard where it is drinkable costs 50 cents per cubic metre of water. And that's the cheapest I can find in the world. 1 kilogram of nitrogen leached off a farm will make 88,500 litres, so 88 cubic metres of water undrinkable, exceeding that standard. That's from 1 kilogram of nitrogen. The average dairy farm in New Zealand leaches 28 kilograms of nitrogen per hectare per year. So if you work that out over the whole country, it comes to $2.4 billion a year if you had to clean that water up to get it back, not to the protecting the fish standard, but just to the standard from here to here to make it drinkable again. So you start getting the picture that I'm talking about here, that the costs are not being borne by the industry, and they're not even being borne by us, but they will be borne by future generations. And that's the point that I'm trying to get across. So the things that are driving it: nutrients, sediment, these are what's driving the declines, invasive fish species, water extraction, the physical impacts, dams, stop banking, irrigation, all that kind of thing. So things we've known about for a long time. I'm probably going to take too long, so I'll rush through this, but this just kind of shows you where we went wrong. All of those yellow lines there are nutrients. So we've got cows peeing here, we've got the dairy shed discharge, we've got town stormwater, we've got horticulture, septic tanks, sheep farming, maybe 2 to 5 kilograms per hectare per year of nitrogen, 5 to 10 from the beef farming, 28 and up to 160 kilograms coming from dairy if it's in really light soils and it's irrigated. But under what we've been doing up until now is we've only required consents for what's coming out of the pipes and what's coming out of the dairy shed. Really small part, maybe 20% at most of the problem is what we've been stopping. So we've missed the biggest impact of all, the 80% that comes from all of the other places that don't come out of the pipes. But we've only controlled 20%. That's how we've missed the boat. That's how we've managed to get to where we are. So unregulated intensification. So we had this fresh start for fresh water, which we've been waiting for so long. So since the RMA came out, we were supposed to have a national policy statement back in the 1990s. We finally get one a couple of years ago. But here's what I want to show you what, and I'm sure Jeff's going to come back to this stuff. But just to give you an idea of how we've gone backwards, these are the new bands for nitrate. So if it's in this level here, it's an A. If it's in here, it's a B. If it's in that upper bit, it's a C. And then right up the top there is the bottom line. So what I've got along the bottom, starting from that far end, is just a bunch of New Zealand rivers going from the Waitaki, Clutha, Mackenzie's, Hutt River, a whole lot of them, the Lake Rotorua tributaries. We don't, everywhere in New Zealand scores an A until we get into the really worst of them that are flowing into Lake Rotorua. Into the B band is the Mississippi River, the Yangtze River in China. Mississippi River is a shocker for nutrient. There's a huge dead zone off there, but under our new system, it will score a B.
What?
And then we've got the Canterbury, the red line is the levels that are set for the Canterbury water management strategy. Then I've got the Seine River and the Thames River in England. The Seine and the Thames would still come out as a C. They wouldn't breach our bottom lines. So this is our new levels that we set in this country under the national policy statement that this government is telling us is going to be a fresh start for fresh water. So you can see why I'm quite cynical about what it's talking about. And this is just showing you, so when you use this and you plot it out, the purple colour is where you fail the bottom line. So everywhere in New Zealand would be fine except for a couple of rivers in South Canterbury. They've set the levels so that nowhere in New Zealand would exceed that level. This is this map on the right, those red lines there are where the rivers exceed the 0.8 milligrams. So I said, here's the 11 milligrams that you can't drink, here's 6.9 that kills the fish, here's just around 1, which is where it starts to cause the growth that causes all the problems. And you can see pretty much a map of dairying in New Zealand. Waikato, Taranaki, Manawatu, a little bit of Hawke's Bay, Canterbury and Southland, all already exceed those levels which under our previous guidelines were less than 1, and we've already exceeded that over most of the country. So this is the reality of where we are with fresh water. So you can see why the limits were set much higher. Okay. So what is ecosystem health and how do you measure? What are the crucial parts of it? And I'm going to have to skip through this because I'm running out of time. But water temperature is really important. Oxygen is really important, but not a snapshot of oxygen. You have to measure that variability. If you go in the middle of the day and take an oxygen sample, then you're going to get that middle of that variability and not even know what's going on. You need to measure the clarity, but it's really important and I'm going to talk about this after this slide. The deposited sediment is really important. The biological communities, the fish and the animals that live in there are the best way of telling you how healthy it is. I mean, it's so obvious that you can measure all these chemical things, but really what will tell you what's going on is what's living in the stream. The IBI and the MCI, we have a whole lot of things that will measure that. Water temperature, this is what's in the NOF, the National Objectives Framework, which is part of that national policy statement, the numbers that go with it. No oxygen only below wastewater treatment plants, and that big variation, worst in the world, that worst that's been measured in the world, that's nowhere near a wastewater treatment plant. Under this new policy, and then we only have to measure it there. We haven't got sediment in there. Biological communities, not included. The periphyton, the algae that grows on the river, that's a really good measure of the ecosystem health, and it is in there, but only the biomass, which means you have to do a chemical analysis to measure how much is there. The physical impacts that I talked about, the nutrients, not there. Physical impacts, not there. The nutrients only at those toxic levels. The pathogens, the things that make you sick, the cyanobacteria and the water clarity are the other things there. So what they've done is that they've changed the rules. So instead of being Ministry of Health guidelines, they've now changed it to secondary contact, which is 1,000 coliforms per. So if you're safe if you're wearing waders if you're in a boat. I don't even know how they came up with it because I don't think the pathogens are going to eat your boat. But anyway, secondary contact. So we've dropped that standard that we had before. Again, this is looking at that contact recreation where 90% of the lowland sites failed that Ministry of Health guideline. Here's the new level, and once again, nowhere in New Zealand exceeds the level. The cyanobacteria, this is really, I've got the slide coming up. This is the Manawatu River a couple of months ago. This black stuff is cyanobacteria. The green stuff's algae, the black is, and it forms mats on the faster flowing parts of the river. This is the stuff that the dogs lap up and it kills them. You know, I don't know if it happens around here. It certainly happens in Auckland, it happens in Wellington in the Hutt River, it happens in the Tuk River in Hawke's Bay. Because dogs jump in their great big tongues and they flick a bit of that back stuff in their mouth and they're dead. It's only a matter of time before one of our kids is playing in a river and grabs a bit of that and puts it in their mouth, and then we're going to have a dead kid, and then we might have some activity, probably depending on whose kid it is. But guess what? Benthic cyanobacteria is not included under the new standards. So the planktonic stuff that's in lakes is included. Not all that black stuff will be toxic, by the way. It can be toxic or it might not be toxic. You don't know without testing it or eating it and seeing if you die or not. But you have to treat it as if it all is. And that deposited sediment is really, really important. But I have to say that this is the National Objectives Framework, but the National Policy Statement says that we're going to protect freshwater life-supporting practices and life-supporting capacity, ecosystem processes and indigenous species, including their ecosystems. And it says that we won't let it get worse. So I still don't know, and nobody seems to be able to tell me, are we going to say nothing's allowed to get worse? And if we are, then what are we going to use to measure if nothing's going to get worse? I feel that it's only going to be what's in the National Objectives Framework, which isn't going to measure any of these things. So I don't know how or why you even have a National Objectives Framework if that wasn't going to be the thing you were going to use, but that's still, no one can nail that down. So nitrate toxicity is what happens, so you have a tank full of water and you hold everything constant and you add nitrogen until the fish die, or some of the fish die, and that's when you decide what that safe level is. In reality, it doesn't happen like that. When things get worse, the oxygen drops, the temperature goes up, all these other changes happen. It's so artificial to talk about nitrate toxicity without looking at all of the other things that happen. This is what it looks like. That's what periphyton looks like. The growth that's near that place where the GPP where the world's worst. This is what it looks like in the Oroa River. And under the new standards, that scores an A or a B.
What?
So that river that goes like that in summertime, they've just done the analysis on it and it's scored an A or a B for periphyton under the new standards. This is one in Hawke's Bay that isn't. And that variability is not long before it kills them. This is what happens. Okay, so just quickly what sediment does to streams. And this is a little bit of work, or a big bit of work that one of my students did. So what we did was we radio tagged, we put pit tags, some transponder tags into 130 fish in this little stream that you can see Amber standing in there. What she's got is the reader, and you wave that over the stream, and when it picks up one of the tagged fish, it beeps, so you can see exactly where they're living. So she did this work for 2 years, lived by the river for 2 years, and monitored where these fish were, 136 fish. And this is the map that she worked on, so she could see exactly where they were at each time, and we could calculate. So months of effort went into this work, 6 months of work went into preparing the site, tagging all the fish, letting them go again. The first day, she went out and picked up 11 fish and thought, oh, this is just the whole thing. She was crying. The whole thing's a waste of time. 11 fish out of 130, what are we going to do? Next day, 13 fish. None of the original 11. Next day, 10 fish or something. None of the original. It was 5 or 6 days before she picked up any of the original fish again. And what it turned out was that what was happening was that 90% of the time, those native fish were down in the interstitial spaces between the rocks and boulders. That's where they live, down, way down. And so by the time you get this kind of thing happening, where all the sediment's built up and so that the rocks are just sitting in sediment, or there's so much sediment, all you can see is sediment, then all of that habitat's gone. So I liken it to an apartment building. So instead of people living, like the fish living at all of those levels, and in that stream, we could do some really accurate monitoring on the fish that were there. There were 433 plus or minus 2 or 3 fish living in that river, in 100 metres of that river, and you go to the stream next door that looks like this bottom one here, and the stream on the other side that looks like that bottom one there because they're in different, one's in pasture and one's in pine, and you'd be lucky to get 4 or 5 fish over 100 metres versus 433. When we went searching for them at the end of the experiment, we found some a metre down in the substrate.
Wow.
That's how far down they move and live in that, and they just come up when they want to feed. And so when you have sediment built up to that level, you've lost all that. And that's got to be part of the reason why so many of them are missing and threatened, because you've lost all the places that they used to live in. But we don't measure the positive sediment. And that's the impact it will have. So this is what I think that we're doing. We've got a freshwater crisis because we didn't measure the things that really count. And instead of facing reality and starting to do something about it, we get this national policy statement that says all these great things, but the numbers behind it mean that nothing will change. In fact, it will go down. And it just, I've already kind of said these things here. So we really need to relook at that, or make sure that things can't get worse is part of that. We don't let anything get worse. We only allow things to get better. And there's a whole lot of ways of doing that, but the important thing is that it's not an argument between economy and environment. It only looks like that if you don't measure the true costs of things. So that nitrate example, that $6,600 not to do it versus $240,000 to clean it up afterwards. If you only measure the revenue, which is what Ministry for the Environment did when they analysed this stuff, if you only look at if you have to reduce farming or you're not going to consent another dairy farm in this catchment because of the impacts it's going to have on the river, they will tell you that it's going to lose you X million dollars of revenue. They haven't factored in the cost of, if they did that, we're all going to have to clean it up or put up with unswimmable rivers or put up with rivers with no eels in them anymore or no fish in them anymore. That part of the cost they didn't include in the analysis. The fact that those ecosystems are valuable to us as healthy and they only measure the loss of income. So this is to finish. This is my dog Brian, and he looks really worried there. He never used to be that worried. It's only because I've been telling him all this bad stuff. Thanks very much.
Most thorough and thorough critique, and putting the way forward. So I guess I've taken it to the floor for any questions. If you put up your hand would be good. I see there's a real diversity of folks here and to work with you all. So yeah, looking for it. Oh, Tina.
Thank you, Mike. That was a really informative and important portal to be delivered this evening for us. I was just wondering if, because you've worked right across the country and you've seen a range of different types of approaches to freshwater health, if you have an idea, oh thank you, whether or not you can give us any indication of what works. So in your observations of where you see kind of well-being existing in freshwater systems, what are the characteristics of the council approaches and of the community approaches that have contributed to the well-being? So what are some of the things that we might be able to do here to result in more well-being for our waterways? And also, if you could give an indication of what you think are probably the major contributors to